For our last experiment that we're going to be doing with this same setup, we're going to use a modern day temperature probe. And the one that we're working with is a Vernier Go Direct temperature probe. So we have the same setup where we have a paper towel fastened by a twist tie onto the end of it. What I'm going to do is very briefly, after I set up the program, the free graphical analysis app from Vernier, that will allow you to connect to this via Bluetooth, or you could do it by USB and plug in a wire. I am going to add the alcohol onto it and see the advantage of having technology help you out with the equipment itself. So I'm going to stop sharing off of my document camera, go back to screen share again, but now pick Vernier Graphical Analysis, which I have open. And what we need to do is to set up the program, the app, so that it will actually do a connection to this particular device. So I'm choosing new experiment. I'm doing it from a sensor that I'm going to data collect from. If I had this on a computer running Logger Pro, or if I had a LabQuest, which is a handheld unit that would run this, you could do a data sharing either via Wi-Fi, in terms of that connection, or again, hardwired, or we could do manual entry of data. So I'm going to set up the experiment from sensor data collection. It will do a search to see if there's any devices that are close by. There's also a number that goes along with the temperature probe that you could just type in this number and it would come up. And when I connect to it, it's going to set it up and assume that you want to do a temperature reading. It's showing you that your scale is going to go up to 50 degrees in Celsius. And then down in the bottom right-hand corner, it has a small meter. Did I switch over so you can't see what I see, or vice versa? Yes, I switched back to the document cam that was in the background. Anyway, I can set this up so that I will see maybe that meter a little bit larger. I could also set it up so that it would have a data table running next to it. So if I set it up in that fashion, you can see what's being collected in real time. And the mode for this is that it's going to do 2 samples per second, and it's going to run for 180 seconds. If we wanted to, we can go in and change the variables. Like we know, for example, down here, we are not going to have a 50-degree temperature. We were looking at about 26 degrees or so when we started. So if I make that 30, it'll just spread it out a little bit. You don't have to do that, but we're good to go. So let me hit the collect button, get a background temperature that this is at. So we're at about 26.4. See the data showing up. It's showing up live. And I added about 20 drops like I did before. And you will begin to see the temperature starting to drop off, and you're getting a graph being displayed automatically. As far as the graph options, right now it's doing a line plotting of the data. Now, many scientists say that they would prefer not to have that as an option. So on the fly, while it's running, you can come back to these edit graph options, and instead of doing lines, just show me the individual data points. It's not going to make a big deal of difference in this case because we're collecting so much data. If you still realize that you're not going to probably get down to 0 degrees, instead of going and messing around with the graph options, if I just double click anywhere on the graph, it'll rescale it. So you could look at the average slope of this line as it's cooling down and get an idea of the rate at which it's dropping off and relate that back to looking at its intermolecular forces. You could compare this to other ones that you would have as well in terms of other liquids that you might run and do a comparison. If you wanted to stop early because you see that it's flattening out, some of these liquids evaporate so fast that they almost dry out in 3 minutes, and the temperature will start rising again at that point because now it's warming back up to that room temperature value that you started with. If you do the slope, you have to pick a point where it starts to flatten out. And consider that you're looking at just the rate of how it's dropping. We're down by the speedway here, so that was the sound you may have heard. And there's all kinds of analysis tools that you can employ as well. You can look at viewing statistics. You can apply a curve fit, and then it gives you all kinds of options about what kind of fit you might want to use to see if it will match that. So if I wanted to do a portion of this and just look at this part of the curve before it starts to flatten out and doesn't stay on that straight line, if I do a linear fit there, I now will have a slope that would apply, and that slope will be my rate of evaporation, my quantitative rate that I have. We're starting to level off at about 17 degrees, which is pretty close to what we got using the regular thermometer, except I have the graph already done. Now on my eBoard page, check that. It didn't fit on my eBoard page and it wasn't able to open it up from there, but on my Google Drive, which I shared with you, you can find a folder that will contain other liquids that have been evaporated. And what I would like you to do as part of this lab is to go in and look at, what if I was doing a different alcohol compared to this ethanol? What if I was looking at methanol? Or what if I was using rubbing alcohol, which is 2-propanol? How are they different structurally? What is going to be the difference in terms of the intermolecular forces that are involved? What if I throw in something like acetone, which is a ketone? The organic name could also be propanone for that. So what kind of bonding is involved there? What if we take just a straight hydrocarbon like pentane or hexane? So you could even make predictions with this tool. You can play around with it. So you say you want to add a prediction. Where would I get water if I did this? Well, water's probably not going to evaporate as fast. We can anticipate what kind of bonding water would have relative to looking at the ethanol, which is 2 carbons hooked together in an OH group, but then the other carbon bonds are to hydrogens. So you could predict before you actually do the experiment. So play around with it, take a look at it. We'll come back together again after our little break where you have a chance to use it and discuss. Okay?